Hi class. So today we are learning the 6.4C lesson on circles, angles, and scaling. I think the key word that we want to focus on today is the word scaling. And let's go ahead and start. Examine the figures below. Segment BC has a length of 5 units. Okay, so right now we have two pictures. We have a small triangle and we have a large triangle, and we're trying to see if they are related. Now, visually, they do look like they're related. It says that BC has a length of 5. Let's also just try to look at like segment BA. So BA has a length of 3. And AC, the segment AC, has a length of 4 units. Okay, so if these two shapes are truly related and similar, then we would say that there might be a scale factor, right? So that keyword is the scale factor. What did you do to the small triangle to make it the large triangle? And let's go ahead and take a look. So FE, the segment of FE corresponds with the segment of BA, right? Corresponds just means that they are related to another. They have the same orientation. Like this is the vertical line of the triangle. This is the horizontal line. And you can see that the segment BA is 3 with the segment FE being 6. The segment AC is 4. What do you think the segment EG should be? Right? So this one is 8. Okay. And then without even checking, obviously you can check via a ruler or a protractor of some sort, a measuring utility. But you kind of already know that since these corresponding sides have the same ratio of 6 to 3 or 8 to 4, you kind of already know that FG has to be 10. Okay. It says write a complete sentence explaining why the figures are scale drawings of one another. Why are they scale drawings? You may use a protractor. Use words like corresponding angles, scale factor, corresponding sides, and circle. Okay, so you would say the two triangles are scale drawings since the scale factor from the small to the large is 2. So the scale factor being 2 just means that in order to go from this to this, we always go from the small triangle to the large, right? You could also go from the large to the small, but you'd realize that that scale factor would be 1/2. It would be the reverse. The reciprocal, okay? We've talked about this in class before, so this is somewhat of a review. You could also say the corresponding sides of the large triangle are 2 times as large, right? The corresponding sides of the large triangle are twice as large, are twice the length. Okay, it's a lot of detail, but I think that's good enough. That's all you need to really write, and let's move on. Okay, so it says, remember that you have given that BC has a length of 5. What is the radius of each circle? Okay, so remember, class, that this is considered the diameter. So the diameter is, remember, it's twice the radius. So for the small triangle, the small circle, I would say, the small circle has a diameter of 5, but it also means that it has a radius of 2.5. The large circle has a diameter of 10, which means its radius is simply just 5. Now, is it a coincidence, class, that the radius for the large circle is twice as large as the radius for the small circle? I hope you guys are all shaking your head and saying no. It is not a coincidence that the large circle's radius is twice as large. Okay? But now we're getting into something a little bit more complicated. If you multiply the dimensions of the small triangle by 2, do you think that the area is going to be 2 times larger? Well, visually, does it look like this triangle is actually 2 times larger than this triangle in terms of area? I hope you guys are all also shaking your head and saying no. So I'm going to actually draw something that you may have noticed, and you start to realize, wow, this triangle right here could actually fit into this triangle 1, 2, 3, 4 total times. So we multiply the dimensions by 2, but what happened to the area? Okay. You can see that the area became 4 times larger. So let's go ahead and calculate the area of small. So I'm going to write area of the small. The area of the small triangle is going to be 3 times 4 divided by 2. Remember, class, that the area of a triangle is always the base times the height divided by 2. Okay, so the area or the base was the base is actually 4, but you could reverse them. You could write 4 times 3. 4 times 3 is going to equal 12. 12 divided by 2 is going to equal 6 units squared. Whereas the big triangle, so I'm going to write area of large, is going to have, let's zoom out a little bit. The area of the large triangle is going to have the dimensions will be 6 times 8 divided by 2, which gives me 24 units squared. Okay, the small triangle is 6, the large triangle is 24. Why was it not 2 times larger? That's kind of like the theme of today's lesson. Why was this large area not twice as large as this small triangle? And it's really because area is two-dimensional, right? So I'm going to just write right here, area is two-dimensional. And if it's two-dimensional and you multiply each dimension by 2, you're actually going to make the overall area 4 times larger. Okay? Classify the triangles by their sides and their angles. Well, it does look like the triangles have a right angle right here, and all the sides are different. So we know that the triangles are first and foremost, they're scalene. We also know that it's a right because the angle is right, and it's a scalene right triangle. What is the area of each circle? Okay, so this is kind of, now we have to go into the formula for a circle. And remember from the previous lesson class that we know that the area is pi r squared, or simply pi times the radius times the radius. Okay, so for the small triangle, we know that the radius was 2.5. So I'm going to write 2.5 times 2.5 times, let's go ahead and use 3.14 for pi. Remember that this is an approximation, but that's okay. The majority of us use 3.14. So again, this is for the small. And 2.5 times 2.5 is going to be 6.25 times 3.14. Oops, 6.25 times 3.14, and I'm getting 19.625. 19.625. Remember, don't forget to write units squared. The larger triangle has a radius that's double, right? So the radius this time for the large is going to be 5 times 5. And you can already tell it's 2 times larger here and 2 times larger there. So that's not going to make it 2 times larger in area. It's actually going to make it 4 times larger in area, right? So 25 times 3.14 is 78.5 units squared. We're not surprised by that. That is something that we expected. How many times bigger is the area of the bigger circle than the smaller? The large circle is 4 times larger than the small circle. Okay. Scale factor was 2. The scale factor, again, for the original triangle was just we used a scale factor of 2 because we wanted to make it 2 times larger. But in fact, the area is 4 times larger when you do that. Okay. All right. So let's take a pause right now and let's finish the rest later.